to perform an experiment. The name of this experiment is NAND gate as a universal gate. So this is another gate. So already I have discussed the basic gates in my earlier videos. So NAND gate is not a basic gate, but by using NOR gate we can realize all the three basic gates. That's why it is called a universal gate. So the aim of this experiment is we have to study the NAND gate, and by using the NAND gate we have to realize the other three basic gates, that is OR gate, NOT gate and the AND gate. So first I had made the connection for NAND gate for realization of OR gate using NAND gate. So the basic circuit diagram is like this actually. So here it is shown three NAND gates are using. So here, so in the first NAND gate, one input is coming, but both the two input ports are shorted. Similarly, in this NAND gate also, the two input ports are shorted, and here one input is coming. So we had made this connection like this. Here, this one is the one input, and this one is the second input which we have given to the NAND gates. Again, the two output of the two NAND gates are connected to another NAND gate as an input. So finally, the output of the final NAND gate is connected to this LED port connections. So this is the connection diagram for NAND gate for realization of OR gate by using NAND gate. So we will now justify whether our connection is okay or not. That we will justify. So already we have known our OR gate realization, OR gate logic is that when both the y equal to, that is output equal to a plus b. That means if one of the input is 0, one of the input is high, then we will get a high output. So that will verify. So first of all, both the two input are 0, so we are not getting any output. Secondly, suppose we are giving a high input, so we also have seen that our output is also 1. Again, we can change, that is second input high, then also we are getting a high output. Now we will try for both the two input high. So this is the position for both the two input high. Now in this case also our output is high. So that means by this combination of NAND gate we can realize the OR gate. So secondly, we will try for realization of AND gate by using NAND gate. So this is the block diagram. So from the diagram we can see that we need 2 NAND gate for realization of an AND gate. So the output combination of AND gate is y equal to a into b. That means if one of the input is 0, then we are getting a 0 output. So according to this circuit diagram, we are doing the connection. 2 inputs are given to the NAND gate, and the output of the NAND gate is given to another NAND gate, and from the second NAND gate we are connected to the final output, that is LED. Now suppose we are putting a 0 1 as an input. So that means one input is high but another input is 0. So according to AND gate table, we are not getting any output. So it is verified. Now we are putting both the two input high. So by AND gate table, so we have to get a high output. So we are also getting a high output. That means it fulfill the AND gate table, truth table. That's why we can say that by using this combination of 2 AND gate, we can realize the AND gate. So our next part is realization of NOT gate using NAND gate. So for this we need only one NAND gate. So as it is a NOT gate, so we are giving one input. So one input is given to the NAND gate. So that our input port of the NAND gate is sorted. So by using this, next the output of the NAND gate is connected to the LED. That is the final output. So according to NOT gate, whenever we put 0, we give input 0, then we are getting output 1, and whenever we put 1, then we are getting output 0. That means the complement of the input. So in this situation, we are not giving any input. That means both the two inputs is 0. So here output is 1. Again, if we put input 1, then we are getting output 0. That means it fulfill the truth table of NOT gate. So this is the realization of NOT gate by using NAND gate. So thank you everyone.